Okay, example number 3. E to the x over y equals cosine of y squared. Find y prime. Well, believe it or not, y prime is the same as dy dx, so I'm going to go ahead and just write that next to it. A lot of times when I give examples, I like to word the directions differently, even though they mean the same thing, because you never know what you might run into as far as directions go in calculus. This is definitely implicitly differentiation. We're taking derivative with respect to x, and we have a y and a y squared. We have one x in the equation. Let's go ahead and do step 1, which is to implicitly differentiate. And what that means is taking derivative with respect to x. Now over here, we have a chain rule. Okay, we know that derivative of e to the anything is that thing. So we know we're going to have e to the x over y, but we have to multiply it by the derivative of that, x over y. So it's the quotient rule and chain rule and implicit all in one. Over here, we will have the chain rule. Derivative of cosine is negative sine, but we have to take a derivative of that inside, which would be 2y dy dx. So the right's not too bad. So let's just write it that way. Take the derivative of each side is another way of expressing this. All right, move to a different column here, I believe. All right. So the derivative of e to the x over y is e to the x over y, but we have to take the derivative of the inside using the quotient rule. And remember, that's f prime d minus f g prime over g squared. Our f is x, so f prime g minus f g prime. Our g is y. Okay, so f prime g minus f g prime over g squared. So g prime would be dy dx. Now, why did I write y prime? It's the same thing as dy dx. And, you might want to do this when you're doing these problems because writing out y prime is a lot shorter than writing out dy dx. Okay? I'm not sure if what I wrote you can just see, so I'll rewrite it. Writing out y prime is much shorter than writing out dy dx, and they mean the same thing. Okay, so derivative with y with respect to x is just y prime. Okay, equals. Now again, the derivative of cosine of y squared is negative sine of y squared. Take the derivative of the inside would be times dy dx, and again, instead of writing dy dx, we can just write y prime. All right, now step 2. Isolate all y prime terms on one side. So this is again the same as dy dx. We have a y prime term on the right, and we have a y prime term up at the top of this fraction here. So this is going to be tricky, like a puzzle. What can we do? Well, the first thing we're going to do is get rid of this fraction by multiplying both sides by y squared. What that will in effect do is just go ahead and cancel these out. All right. So you'll just have, now I'm going to simplify the top as well. So this is y minus xy prime e to the x over y. And again, those canceled out. So it's just left with this. On the right, since we multiplied both sides by y squared, it'll be negative. And I'm just going to, okay, so this will become 2y times y squared is 2y cubed in the negative. So it'll become negative 2y cubed times y prime times sine y squared. Now you can begin to see why I did that, because we were ultimately trying to get all the y prime terms on the same side. Now the issue here is we have a product of e to the x over y and y minus xy prime. The only way to get all the, so this entire thing, by the way, let me go ahead and circle this. This entire thing is an expression that contains y prime. In order to make this work and get all the expressions of y prime on the right, you can't just divide by this because this y doesn't contain a y prime, right? So we're going to have to distribute this into both of those. And when we do that, the second term that we get will be the term that has the y prime. The first term here will not. the second term we get, we will add to the other side. It's kind of tricky actually, but explaining it here. So after we distribute that, we get that. And now we have two terms that have a y prime, this term and this term. Since they both have a y prime, and take this one and move it to the right, that will leave us with just one term that doesn't have a y prime, which is that one. So I'm going to add this to both sides. Okay, sometimes I just add it on the same line. It's the same thing. And when I do that, again, we have both terms with a y prime on the same side of the equation. And it's only two terms. And we do that again so that we can pull out a y prime. So we're going to pull that y prime completely out. Both of these pull out to the front. And then we'll be left with whatever's left that's not a y prime. So the negative 2y cubed sine of y squared plus e to the x over y is what we'll be left with. And there you have it. And again, the reason we do this, and again, this is just like dy dx. Y prime is just easier to write than dy dx. This might be something you just get used to doing. Now that we've done that, we can just divide everything, both sides of the equation, by this and get rid of it, right? After we've pulled out that y prime. So we're going to get y by itself, and to do that, we're going to divide both sides by this entire thing that's not y prime. And that's our answer. Okay, I think I did actually I did do some simplification, which we'll talk about in a second. Maybe some simple one. But yeah, again, that's the same thing as getting dy dx by itself. This is the same thing. Keep writing that so you don't forget that. So this is our derivative. And again, if you wanted to find the slope of the tangent line, if you had a point, you plug in the x coordinate and the y coordinate, and that'd give you the slope of the tangent line for this particular derivative. Doing some simplification, our final answer is e to the x over y divided by negative 2y cubed sine of y squared plus e to the x over y times x. Final answer for this one. All right, that's it for this example. If you have any other questions about it, let me know.